Hi there. In this tutorial, I'm going to demonstrate how to fracture an object in a particular place and then how to appear to smash it. If you enjoy these tutorials, don't forget to click like and subscribe. Feel free to comment or ask questions or even dislike the video. And if you don't like the video, I'd be very interested to see what the issues you spotted were so that I can improve going forward. If you're a Patreon supporter, I do upload these files for any use available to my Patreon supporters, and I upload tutorials quite regularly. So let's start the tutorial. In my demonstration, you can see I've just created a couple of bones and I'm appearing to smash the one bone with the other. But you'll notice the bone is breaking in a particular place. It's not just all generally shattering. So to begin with, we need our bone object. I'm not going to model an entire bone during this tutorial. It would take quite a long time, but just very briefly, the way that I did that is I added an image. You can just drag an image out of a folder into Blender now, and it will put an empty in there with the image in it, and then just create a plane. I'll rotate it on the X90, move it forward a little bit. We'll go to orthographic view, go into edit mode, and then I just delete 3 of the 4 vertices, select that remaining vertex, and then just start pressing E as you model the outline of your bone. Now obviously you can do a lot of detail here. It is useful to have a reasonable number of vertices, but you don't want to go mad. I'm just really going very roughly now. We're not trying to model this particular bone, so it doesn't matter about precision. And then for the last 2, you can just press F with them both selected and it will just join it. So that gives you the outline of your bone. And then we can just select that empty and turn it off. Select all the vertices, look from the side. Let's make sure it's completely flat. I didn't do that properly. So scale Y0 and look from above. And that looks okay as well. Then just E and then click GY and you can just pull it out a little. And then E again and GY. And this time, if you just press S for scale, it'll actually scale wrongly. So you'll see it's all scaling in towards the middle. It's scaling at what seems to be different rates because it's long, so the scaling doesn't work same in the horizontal as the vertical. If you do Alt S, you can see it does it slightly differently, and that gives you, basically thins it down, thickens it if you go the other way. You will need to still adjust a few things, and you can see it's gone slightly wrong up there, so we'll just move those in. This is another reason you want to keep the number of vertices down. And then there's a number of things you can do. We can just press F, for example. But what I would then do is use the K or knife tool and just add a few additional cuts there. May have missed one there. Really just to give you enough geometry to play with. And I'll put one more there and there, I think. So we can just select that end set of faces and we do Control B. You can also add some, you will mess the geometry up a little bit. So you will want to correct that. But then we'll put a subdivision surface on there with Control 2, and you can see probably needs a bit of extension in the Y, so scale Y, pull it out a little there, not too much. You can see we've only made half the bone at the moment. But before I make it a whole bone, what I want to do is add some thickness, because the whole point of the bone is it's not solid. If you wanted a solid object, then that'd be fine. So I'm actually going to apply that subdivision surface, and we'll set it to smooth shading as well. And now I'm going to add a solidify modifier, and we can play with the thickness. See, we are getting some dodgy geometry in certain places, but it should be okay. And I've turned off fill rim because I don't actually need that face to be filled. And you can see I should have tidied this area up a little bit before I added the solidify modifier, but it should be okay for our purposes. It's messing up there, but we'll go with that and we'll see how it goes, accepting that the geometry is a little strange just there. And I'm just going to apply that as well. And then I'm going to add a mirror modifier. Again, all this applying not strictly necessary. And I'm going to add it in Z and go to edit mode, turn on clipping and GY just to join it together. Geometry is really quite bad just there. And we can see there's a few normals issues in there. So I'll just correct those. Under mesh, normals, recalculate outside, and there you go, let's fix those. So it needs a little bit of tweaking and work, and I know there's some geometry problems there. What I was just doing there was just making sure that the inside was on the inside and the outside was on the outside. So on that subject, I'm going to turn cavity on because it makes things easier to see. And then we're going to go up to here and we're going to select face orientation just to make sure we've got blue everywhere, which means we're only seeing outside faces. We are, so I'm just going to apply that now. And the last thing is, you notice the origin is down here. So we'll go up to Object, Set Origin, Origin to Geometry. Now it's back where it should be. So we can turn that face orientation off now. And we'll give the bone a basic material. But I did this in Eevee just for the speed of rendering, really. So we'll need to add a lamp, which is an area lamp. Scale it up quite a bit. I set it to about 1000 watts, quite a bright light. And it's probably worth having contact shadows on. It just adds a little realism to it. And we'll turn on screen space reflections as well. If we go to rendered view, I'm just going to turn off floor and the grid, and we'll set the background to black. I'll put a floor on there in a moment. So we'll actually do that now. There's a plane and we'll scale that up. We'll just give that a basic whitish color and not too rough, reasonably shiny. So there's our bone, and we'll come to shadows and we'll say soft shadows, which improves it a little bit. So we'll select our bone and we'll say new material for that. And we can initially just set sort of yellowish, brownish color for it. I think the important one with bone is to have a subsurface color as well. I just went with a sort of lightly yellow color and a subsurface amount of only 0.1. So this is what sort of lets light bounce around inside it and then come back out and gives you a little bit more of the feel of it being bone. It's always worth turning on alpha clip and alpha hash, just because we may be using some of that, and I'm not sure, it may affect the way the subsurface works, but you can see there's a slight effect there if I turn subsurface off. It's very subtle at the moment. It'll be more visible once we've broken the bone. There you go. If I put it right up to 0.5, it's much higher. So I'll leave it at that for the moment. It's simulating the light going into the bone, bouncing around, picking up some new color if you like, or being absorbed differentially, and then some of it again escaping from the bone. So the amount of bone it passes through affects the color of the light as well. And it just gives you a more realistic idea of certain materials, plastics and certain organic materials as well, like flesh. So then I'm just going to add color mix node. I'll put that lighter color in the bottom. I'll copy it on the top, but then I'll make it a stronger color, quite a bit darker, and we'll feed that into the base color. So with the factor all the way to one side, we'll get the darker color, and the other side will get the lighter color. It's still relatively subtle. And then I'm going to add under textures, Voronoi texture, and take the distance into the factor. Set to the default, but I set the scale to about 2. Again, the exact scale will depend on the scale of your model and so on. I'm going to add under converters a color ramp, take the Voronoi into one side of that and the other side into roughness. I flipped the color ramp and then brought that in towards the middle. So this is the idea of sort of having pock marks on the surface, and I left it on linear. I also changed the white side to more of a sort of light gray and the dark side to a sort of darker grey. So it was a more subtle effect. And then I added under vectors bump node. Again, take the Voronoi into the height for the bump node height there, and then the bump node goes into the normal, and I set the strength to about 0.1. The scale is actually 200, not 2, so I'll just put that up to there. And now you can see we've got that sort of organic sort of look to it. Bear in mind this is Eevee, so it is making various approximations, and obviously you could spend more time and put more variations into that. So there's our initial bone with its material. So now how do we fracture it, and more importantly, how do we fracture it in a particular place? So fortunately there is a useful little quick effect. Before we do anything else though, I'm just going to press Shift D just to make a duplicate of that bone, and then just press escape so it goes back to where it was. And I'm going to call that bone hole, and the other one is going to be bone fractured. So I'm going to switch off the visibility of bone hole at the moment. They're both in the same place, so you can't tell. So the only one we're seeing is the one we're going to fracture. If I add under object quick effect with that bone selected and just say self fracture, we get this option come up. For the most part, we can accept the defaults. There is one particular one I'm going to change. Because we're going to use physics, it's worth adding something into margin. So margin, this is going to shatter the bone, break it into little pieces. And we're then going to use physics on that. In theory, you could put the physics on first, but it's fine, you can do it after. We're going to use physics on that. But if the objects are in contact with each other, you'll start to get problems. So it's always worth applying a little bit of margin between them. The exact amount will vary, but needs something, some sort of gap between each part. In terms of the number of parts, obviously you'll need to play around with that. But I've just accepted defaults there, and I'll just say okay. Apart from the margin, everything was default. And you can see it does a little exercise on there. You can see the margin on there now. It's quite a big one actually. And there, it's finished. If I turn that off, you can actually see there is my original bone, and there is the fractured version of the bone. It looks pretty impressive actually. So it does retain the original bone, and you can see there are the pieces of the bone down there. In this case it created 100 pieces. So just delete those. But you noticed it had fractured the whole bone all over, and that's not strictly what I want. So I'm going to change a couple of things. I'm going to look from the top and I'm going to click here, which is the annotation marker, and wherever it is I want the bone to break, so let's say here, I'm just going to put a mark there. If you hold your mouse pointer down for a moment, you'll get various options. We just want the normal annotation. So once we've selected our tool under annotate, we can just draw a line like this, and that's going to be where we want our fracture to occur. However, with the defaults, you notice it hasn't even really occurred on top of my object. Possibly some of that is because I had the plane selected. So I'll make sure I've got my bone selected now. We'll do the same again, and you can see it's still not drawing on the bone. So we need to come over to here with our annotation tool selected, and under placement, change that to surface. And now if we do a little cut like that, you can now see for the part of the line that's over our bone, it's actually put it on the bone itself. And that's what we want. We're trying to at least give the cell fracture tool an idea of where we want our bone to fracture. Not worried about these bits either side. So I'm now going to go to Object, Quick Effect, Cell Fracture. Make sure we've got a little bit of margin on there. In fact, we didn't need that much. I'm going to go for 0.001. 100 particles is fine. It will crash sometimes. And the most common causes of crashing of the cell fracture, or for it not completing, is problematic geometry. That's why it's worth making sure when you do it, it's all sorted out. But next we need to say annotation pencil. So that tells it where it's going to start the fracturing process. And now we'll click OK. And you'll notice it's centering what it's doing around that point. So while we've got all of those fractured pieces there, I'm just going to press M and say new collection. And we'll just say broken bones, just to make it easy to deal with them, because there's quite a lot of objects there. So we'll turn off the bone fractured. And we actually are missing a piece of bone there. As I say, that will most likely be because of the issue with the geometry that I didn't fix over here, but you see everything else worked fine because the geometry was okay. I'm not going to worry about that for this demonstration. If we select that one piece, we can rotate that, and you can see we've got a hollow bone. First time I did it, I didn't get a hollowed bone, I got solid, and that was because the normals on the inside were facing the wrong way. So effectively, this inner area was seen as the normals were pointing that way, outward. So that indicated that this was solid, and then Blender got confused because these normals were pointing that way and so were these. So it just made the whole thing solid. But whereas obviously they should be pointing inward for this inner face and outward for the outer face, so blue there inside and blue on the outside when you view face orientation. But once that was fixed, you can see it gave me a hollow bone. And we probably want a bit of translucence on there as well, but I'm not going to worry too much about materials for this demonstration. And you can see we've got a bit of broken bone there. So that's fractured the bone. So I can now just erase that annotation just to get it out of the way. And you can see there's lots of different pieces of the bone here, but at the moment they don't do anything. So I'm going to right click the top of this collection, which is my fractured bones, and just say select object. So that selects all of them. And then I need to hold shift and just click, left click one of the bones. And you notice it's got a lighter, you may be able to see it's got a lighter orange stroke yellow outline. So that's now the main selected fragment of bone. And I'm going to go to physics properties and I'm going to select rigid body. The type is active. I'm not going to worry too much about the mass at the moment. However, the default here is convex hull, which means it's creating a very crude approximation, sort of a lozenge around the shape, which is what it uses to determine whether the shape has collided with anything. Now these are quite complicated little shapes, so we need to select mesh for us to even have a hope of this working correctly. Now with all the others selected as well, if I press F3 and start typing copy, you notice we've got an option here, object, rigid body, copy from active. You can also do it up here under rigid body, copy from active. So that means each one of these parts should now have that option, and you can see they have. So if I just press play now, you can see they just go flying off, which is the normal sorts of thing to happen. It's not really what we want. It's not just falling, they're actually repelling each other. So we'll select our objects again. That one's still our primary object. And if we have a look under sensitivity, we can see we've got a margin of 0.04. So you shouldn't set 0, but we'll put it to 0 for now. And then we'll just say copy from active and see if that's made any difference. Nope. You can tell because it's taken a long time. It's still flying apart. Possibly not quite as bad, but it is. So this is where you may want to look at redoing the cell fracture, but with a slightly larger margin between them. Before we go any further, I'm just going to also put rigid body physics for the plane that we're working on. So we say rigid body, but this time this isn't going to do anything. It's just going to sit there and act like a floor. So we can say this is passive, and we'll just set this to box. So we'll set it to play again. Although it's still exploding, at least we can see it is somewhat acknowledging the existence of the ground. It is falling through it a little bit, and there's always a lot of tweaking that's necessary. Again, we can put a collision margin on the ground, and also we can turn on dynamics and deactivation. And if we open that up a bit, we could tell it to start deactivated. So what this should mean is until there is something to cause movement, something collides with it, the collection should just stay where it is. However, if we've still got a problem with the margin, that's not going to work. So we still have, you can see it's all just flying apart. So what I'm going to do is I'm going to redo the smashed bones, and we'll add a little bit more margin. So just to make it easy, I've put quite a large margin on it this time, and everything else is as I showed you. So we've got mesh for the collision shape for each of the pieces. We've got deactivation triggered, and we've got start deactivated. So now it actually simulates very quickly because there's nothing to simulate. There's nothing moving, and that's what we wanted. If I turn that off, you can see there are all our pieces of bone. We still got our original bone there, and we've got a whole bone as well. So I'm just going to take that whole bone and take that off now. But while it's here, I'm just going to rotate on the Z, something like that, and maybe put it there. So this is where I want roughly this bone. I'm just going to lower the floor a little bit to get to. This is the one that's going to do the smashing. Perhaps we'll rotate that one on the Z 180. And because I wanted to simulate it being swung from a different axis than just the bottom of the bone, I'll add an empty, and we'll put that empty somewhere like that. This just made rotations and things like that a little bit easier to do. And then I'm going to rotate that empty just to line up with the angle I've got that bone at, roughly. It doesn't have to be precise. And then take the bone, then select the empty, Control P and say Object, Keep Transform. And now when I rotate that empty, it rotates the bone. So I'm going to start off, rotate XX, which is the local X axis for that empty, and we'll bring it up to something like that there. And we'll just press I and say rotation. You can start this at any point, and then perhaps we'll go to about 15 frames in, which is less than a second if we're going at 25 frames a second. And we'll rotate XX to just above the floor and I rotation. So if we come back now, you can see it just drops down like that, but that's a bit boring. So I'm going to right click with both of these keyframes selected, and we can speed or slow that later. I'm going to right click that and say interpolation mode, and I'm going to say bounce. So now if we do it, it actually falls a bit quicker and it seems to bounce when it hits. So that's a bit more interesting. The next thing I want to do is make this a physics object as well. So with that bone selected, we'll go to rigid body, but we'll say animated this time while changing it to passive. So it's an animated passive, and we'll say mesh because it's a bit of a strange shape, and we'll see what that does for us. And we're getting the same problem as I had before. I spent a lot of time working on margin and things like that, and it always seemed as if there was a version of the bone which was ahead of where it really was. So if we have a look at this, we may see that it actually shatters, it starts moving before the other bone actually reaches it. So there it is, and while there is a margin on it, it's very small and should in no way be affecting this bone. I think this is a bug. I can't see any reason, given this is under mesh, that should be working that way. And we can even check face orientation, there's no problem there. This is basically a bug. I did find a way around it, and that was to have a physical bone version of this one that was offset further back, because it doesn't affect it at first. It only affects it when it gets within a certain distance. I'll set the margin to 0 again anyway, but it doesn't make much difference. And it doesn't seem to be speed of interpolation either. But before we do that, let's just have a look at that. So we've gone to scene properties, and you notice we've got some settings to do with that. They are all dotted around the place, unfortunately. So the sub steps per frame. So for every frame, it checks where each object is and whether it's colliding in 10 different places within that frame. So we can actually increase that or decrease it or whatever we want to do. One of the other things I wanted to do as well though is to make it a sort of slow-mo simulation. So I ended up setting the speed to about 0.1. That doesn't change the speed at which this object moves, but it does affect the speed at which the whole simulation responds. It may be a scale issue, but you can see it still starts to move there, and there's no way there should be any interaction between these objects at that point. A little annoying. I don't think it used to be quite that bad, but no doubt it's something else that will get fixed somewhere along the line. But just to check, we can turn up the sub-steps per frame to a much higher number, so I've set it to 100 there. Sometimes that will help with some of your problems. Other times it will introduce more problems. I guess when it's doing more calculations, there's more opportunities for errors to come in, and you can see that's not made any improvement whatsoever. All it's done is make it take a very long time per frame. So if I stop it there, you can see it's actually worse in some ways, but certainly it's no better. So that hasn't improved things at all. And solver iterations, so how accurate the simulation is going to be, and we can turn that right up as well. We'll go back to the beginning and start it simulating, and again I can already see it started to jiggle before the impactor had reached it. So you can see there it made no improvement there either. So I think I ended up with a compromise of putting about 25 sub-steps and 25 solver iterations. So more accurate than the default, but doesn't solve this main problem. Again, different scales, much larger scales or even smaller scales, might avoid this problem, or it may be less noticeable. Could be I'm just trying to do it on too small a scale or something like that. So my fix was to actually make 2 of these. So I've duplicated that one completely, and I've got the keyframes down here, and all I did really was just take that one keyframe and pull it this way. So what you'll see now is that one takes longer to come down. So I pulled it too far there, and if it's not clear yet, it will be clear in a moment what I'm actually doing. So this one that's ahead, if I come back a little bit, this one here, I'm going to remove the rigid body effects from, so it's not going to have any physical impact on these objects. So it's gone. This one still does. So you can see it's coming down, no reaction of the shattered parts yet. And obviously that's got there too soon, but this is a bodge. So if I select that part again, I need to bring that back slightly further. You may or may not need to do this depending on what you're trying to achieve. And you can see because the end frame is the same, they do catch up with each other. And all of this is happening in literally a fraction of a second. So if we go on now, so nothing's moved yet. At that point it needs to have moved. So again, I need to bring that other one back a little bit. So it's not much. So it can be a bit easier to see what's going on with the dope sheet. So I've just opened that up here. So I've got bone hole, which is the one we're going to be able to see, and bone hole 001. And they've both got 2 different empties associated with them, obviously. So if I back off, say to frame 3 for the start of empty 002, and we can see it's only just behind the other one. And it might need to be even closer than that. I'm doing the physics simulation at the same time as this, of course. That's not bad. I mean, let's let it simulate and run it closer to normal speed. And you can see they join up because their endpoints are in the same place. So at normal speed, that looks pretty fair. So we'll go with that for this. So again, as I say, this is just a fudge. It's not really what we should need to do. But just to make sure that that never shows up in the render, I'm going to turn it off in visibility there. I'm going to turn it off or disable it in renders. And while I'm here, I'm going to turn on this option here as well. So if we now go back, re-simulating again because I changed something. So that doesn't look too bad, other than we've got this fractured bone. So what we really want to do is we don't want to display that until it starts to break. So it starts to break at frame 6. So at frame 5, we want it visible. If you were just wanting to make an individual object visible and invisible, you can actually turn this one on, which is globally disable in viewport. So if I select this large bone fragment here, if I click that, you can see it disappears, and it will disappear from the render as well. And you can animate that, you can add a keyframe. However, the problem is I've got 100 of these to do, and if you had more fragments, you've got even more. Hopefully they'll fix this. It's been around for quite some time that we haven't been able to animate collections, so it may be a while before that's fixed, unfortunately, but hopefully it will be at some point. I'm not the only one to have had issues with that, so we'll have to do it in materials. So we've got our basic bone material here, and what I'm going to do is make another version of it. The version that's on my fragments I'll leave as is, but the version on here I'm going to make unique. You see there's 158 copies of it. I'm just going to click that, and that will mean the changes I'm about to make aren't going to affect this one. It's unique. If I go back to here, you can see there's now 157 copies of it. All these fragments use that version. And I've also got this bone, which is currently using that material. I want it to use a unique material as well, but it'll actually be more similar to the one I'm about to make for the fragments. So I'll leave it as is for the moment. Call that bone frags. Let's just disable that one again. So all I want to do is just add something to control visibility. Now in theory, I can just do it with this. So you see I've turned alpha off. There's some little glitches here, and I think that's partly to do with EV. They may not be visible in the render anyway, so we'll just animate that for the moment. So I know that at frame 5, make sure this node is selected, the principal node. I know that up to frame 5, I want those fragments to be invisible. So I'm just going to make sure that node is selected, hover over the alpha setting and just press I. And then going to frame 6, I want them to become visible. So I then turn the alpha back up to 1 and press I again. Looks like our rigid body has been lost, but we'll resimulate that in a moment. If we go back to the beginning and let it calculate, you can see suddenly our fragments appear just as the impacting bone comes down. So all we now need is to be able to see the unfragmented version just before. So I'm going to re-enable my what I call my bone fractured, but that's currently invisible because that's using the same material. So now we can give it a unique material, and we'll call this initial bone. We'll click here to make it unique, and then we'll call it initial bone. And obviously what we need to do is the opposite. So this needs to be at frame 5 visible, and I'll press I, and then at frame 6 it needs to be invisible. Now we may have a problem there, but we'll have a look in the rendered version and it's fine. So it's only in the preview where we're getting this artifact. So I'm not going to worry too much about that. So let's let the simulation run a little bit. Again, this isn't the ideal way to do it. It would be better to be able to do it with the collection, but that function isn't currently available. So we know that the bone breaks there. So we'll just look at what that looks like from a rendered standpoint. And I've got that initial bone set to not render, so that's why that wasn't quite right. So we'll just render that. And an easy way to play around with more than one material is just to add the second material into an easily accessible object. So we've got an issue there until those become completely invisible. It's probably a normals issue. So what we'll do is, looks like adding transmission in as well will help. So we'll put transmission up to 1 and we'll animate that, and then we'll go to the next frame and we'll set transmission down to 0. So I'm just letting that run through, and that's basically doing it. Now you notice we are getting a few little strange artifacts here as well in terms of the movement. And you can help to deal with that by, if we go to our bone fragments, so I'll select that bone fragment there. We'll select all the objects, but that's our main selected object. And what you can do is you can apply some damping, both to translation, which is movement, and to rotation. That will start to take some of the energy of movement out. And you can also increase these numbers, which basically mean when the velocity or angular velocity, rotation in other words, falls below this number, this is meters per second, the object will just stop moving. It's no longer going to do that. So you can play with these, and that will help with that. The worst comes to the worst and you're really still having problems, you can play around with the substeps for frame. You can turn on split impulse. Only do that if you have to, and that can sometimes help. I haven't often found it very helpful, but in theory it could. And you can also add things like friction, and so if we let that go there. And what I obviously needed to do was go up to object and just say rigid body copy from active, and while we're at it we can add a bit of friction in there, which will also help to slow things down. Physics simulation, it still gives you very unexpected results in Blender. There's still a lot of work to do there. I think it doesn't work as you think. You know, we expect you hold a ball over a surface, it'll just work, but it doesn't always. So as I say, you can play around with adding more sub-steps and things like that, and more solver iterations even. And sometimes it's a matter of tuning the number of sub-steps and the solver iterations. It's because essentially by looking at more sub-steps, you're more likely to find a point where, for example, one mesh ends up inside another, which then causes problems in the way the calculations work. And that's largely what this twitching going on here is to do with. You just need to play around with these various elements and the measures in here in order to try to get that to work. Again, that margin of 0 may not be working very well. So we can have a look how that's doing now. So I increased the margin possibly a little too high, so it's largely exploding now, but it is at least starting deactivated, so it's not too bad. And there it goes. So I hope you enjoyed that tutorial, and I'll see you in the next one.